exercises. Question 1. Fill in the blanks. 1. 1 milliamperes is equal to dash A. Your options are A. 10 raised to 3 amperes, B. 10 raised to minus 3 amperes, C. 10 raised to 6 amperes, or D. 10 raised to minus 6 amperes. The answer is 1 milliamperes is equal to 10 raised to minus 3 amperes. 2. To increase the effective resistance in a circuit, the resistors are connected in dash. Your options are A. Series, B. Parallel, C. Both ways, D. None of these. The answer is, to increase the effective resistance in a circuit, the resistors are connected in series. 3. 1 kilowatt hour is equal to dash joules. Your options are A. 4.6 into 10 raised to 6, B. 3.6 into 10 raised to 6, C. 4.6 into 10 raised to minus 6, D. 3.6 into 10 raised to minus 6. The answer is 1 kilowatt hour is equal to 3.6 into 10 raised to 6 joules. 4. If a potential difference of 12 volts is applied across a 3 ohms resistor, then the current passing through it is dash. Your options are A. 36 amperes, B. 4 amperes, C. 0.25 ampere, or D. 15 ampere. The answer is, if a potential difference of 12 volts is applied across a 3 ohms resistor, then the current passing through it is 4 amperes. Question 2. State true or false. If false, correct it. 1. The SI unit of charge is volt. The answer is false. The SI unit of potential difference is volt. 2. Voltmeter is always connected in series with the device. The answer is false. Voltmeter is always connected in parallel with the device. 3. The conventional direction of flow of current is from positive terminal to negative terminal of the cell. The answer is true. 4. Silver and copper are good conductors. The answer is true. 5. Resistivity of pure metal is more than alloys. The answer is false. Resistivity of pure metal is less than that of alloys. 6. The electric bulb consists of the filament whose melting point is low. The answer is false. The electric bulb contains of a filament whose melting point is high. Question 3. Match the given columns. The answer is heat generated is proportional to the square of current. The formula used to calculate the heat generated is VIT upon 4.18 calories. Resistance in parallel is used to reduce effective resistance in a circuit. The formula used to calculate resistance in parallel is 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. Resistivity depends on the material of the conductor. Resistivity ρ is equal to Ra upon L. Ohm's law gives relation between V and I, where V is equal to IR. Question 4. Give scientific reasons. First, the material used for fuse has low melting point. Answer. First, the fuse works on the principle of heating effect of electric current. It is connected in series with the device and protects circuits and appliance by stopping the flow of any excess electric current. Second, when excess current flows, heat is generated due to which the fuse wire melts and breaks the circuit. Third, thus, for the purpose of breaking the circuit, when excess current flows, the fuse wire needs to have a low melting point. Second, wood and glass are good insulators. Answer. First, materials which do not conduct electricity are called insulators. Second, insulators need to have high resistivity for electric current as they do not conduct electricity. Third, wood and glass have infinitely high electrical resistance, hence are good insulators. Third, the melting point of filament of a bulb is very high. Answer. First, an electric bulb consists of a filament which becomes hot and emits light when current flows through it. Second, the melting point of filament of a bulb is very high, so that it can get heated up to a very high temperature and provide illumination. Fourth, connecting wires in a circuit are made of copper and aluminium. Answer. The resistivity of copper is 1.62 into 10 raised to minus 8 ohm meter, and that of aluminium 2.63 into 10 raised to minus 8 ohm meter. Since both copper and aluminium have low resistivity and are good conductors, connecting wires are made up of copper and aluminium. Question 5. Define. First, 1 volt PD. The potential difference between 2 points is said to be 1 volt if 1 joule of work is done in moving 1 coulomb of electric charge from one point to another. Second, 1 ampere. When 1 coulomb of charge is passing through any cross-section of a conductor in 1 second, then the amount of current passing through it is called as 1 ampere. Third, 1 ohm. If current of 1 ampere flows through the conductor and 1 volt potential difference is applied across it, then its resistance is 1 ohm. Fourth, potential. The level of electric charge present is known as potential. Fifth, resistivity. It is defined as the resistance of a conductor of unit length and unit area of cross-section. Sixth, electric power. The electrical work done per unit time is called electric power. Question 6. Differentiate between. First, resistance in series and parallel. Answer. When resistances are connected with each other such that same current flows through them, then it is called series connections. While when resistances are connected in between 2 points, such that the potential difference across each resistance is same, then it is called a parallel connection. Series connection is done to increase the effective resistance, while parallel connection is done to reduce the effective resistance. In series connection, the current is same in every part of the circuit, while in parallel connection, the current flowing through various resistances is inversely proportional to the resistances. In series connection, the voltage across each resistor is not the same, whereas in parallel connection, the voltage across each resistor is the same. The resistance of the combination is equal to the sum of the individual resistors in series connection. In parallel connection, the reciprocal of equivalent resistance of the combination is equal to the sum of the reciprocals of the individual resistors. Second, differentiate between conductors and insulators. The substances that readily conduct electricity are called conductors, whereas the substances that do not conduct electricity are called insulators. Conductors contain large number of free electrons, while insulators do not contain free electrons. Generally, all metals are conductors, while generally, non-metals are insulators. Conductors have low resistivity, while insulators have very high resistivity. Third, distinguish between resistance and resistivity. Answer. Resistance is the property of the conductor due to which it opposes flow of current through it, while resistivity is defined as the resistance of a conductor of unit length and unit area of cross-section of a conductor. The SI unit of resistance is ohms, while the SI unit of resistivity is ohm meter. Resistance is proportional to the length, cross-sectional area, and material of the wire, while resistivity of the wire is dependent on the material of the wire. Resistance of a conductor can be varied, whereas resistivity is different for different materials. It cannot be varied. Fourth, high resistance and low resistance. Substances having high electrical resistance are called insulators, while substances having low electrical resistance are called conductors. When resistance is high, a lot of heat is generated, whereas compared to high electrical resistance, the heat generated is less when the resistance is low. Heating appliances have high resistance. Conducting wires have low resistance. Rubber, wood, glass, etc. have high resistance, whereas silver, copper, aluminium, etc. have low resistance. Question 7. State the laws. First, Ohm's law. Answer. The electric current, I, flowing in a metallic conductor is directly proportional to the potential difference, V, across its terminals, provided physical conditions of the conductor such as length, area of cross-section, temperature, and material remain constant. V is directly proportional to I, or R is equal to V upon I. Second, Joule's law. Answer. The quantity of heat H generated in a conductor of resistance R when a current I flows through it for some time T is directly proportional to, first, the square of the current, second, the resistance of the conductor, and third, the time for which the current flows. H is equal to I square RT upon 4.18 calories. Question 8a. Find the expression for the resistors connected in series and parallel. Answer. R1, R2 and R3 are the three resistors which are connected in series as shown in the diagram. I is the current and V1, V2 and V3 are the potential difference across R1, R2 and R3 respectively. V is the potential difference of the circuit and Rs is the resultant resistance of the circuit. Total potential difference V is equal to V1 plus V2 plus V3. This is equation first. By using Ohm's law, V is equal to I Rs. V1 is equal to I R, V2 is equal to I R2, and V3 is equal to I R3. Substituting values in equation first, therefore, I Rs is equal to I R1 plus I R2 plus I R3. Therefore, Rs is equal to R plus R2 plus R3. If n resistances are connected in series, the equivalent resistances of the combination is given by Rs is equal to R1 plus R2 plus R3 plus till plus Rn. Second, in parallel connection, R1, R2 and R3 are connected as shown in the diagram below. The potential difference across R1, R2 and R3 is V, and the current flowing through the circuit is I, and resultant resistance is Rp. The current flowing through R1, R2 and R3 is I1, I2 and I3 respectively. I is equal to I1 plus I2 plus I3. First, according to Ohm's law, I is equal to V upon Rp. I1 is equal to V upon R1. I2 is equal to V upon R2. I3 is equal to V upon R3. Substituting these values in equation first, we get V upon Rp is equal to V upon R1 plus V upon R2 plus V upon R3. Therefore, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3. If n resistances are connected in parallel, the equivalent resistance Rp of the combination is given by 1 upon Rp is equal to 1 upon R1 plus 1 upon R2 plus 1 upon R3 till 1 upon Rn. B. Find the expression for resistivity of a material. Answer. Resistance of a conductor depends on the length L and area of cross-section A of the conductor. R is directly proportional to L and R is indirectly proportional to A. Therefore, R is equal to rho L upon A, where rho is called the resistivity of the conductor. If L is equal to 1 meters and A is equal to 1 meter square, then R is equal to rho. Thus, resistivity of a conductor is the resistance of a conductor of unit length and unit cross-sectional area. Therefore, rho is equal to Ra upon L ohm meter. Ohm meter is the SI unit of resistivity. Rho is equal to Ra upon L, the expression for resistivity of a material. Question 9. Answer the following. First, P and Q are the main wires of same length and different cross-sectional areas and made of same metal. Name the property which is same for both the wires and that which is different for the wires. Answer. First, resistance of the wire is dependent upon the material of the wire, hence resistivity of both the wires is same. Second, resistance is the property which opposes the flow of current and it depends on length of wire and cross-sectional area of the wire. Third, it is directly proportional to the length and inversely proportional to the area. Since length and cross-section of wire is not the same, the resistance of both the wires cannot be same. Therefore, the wires have different resistances. Second, resistivity of some materials is given below. State which one will be the best conductor. Copper resistivity is 1.62 into 10 raised to minus 8. Resistivity of aluminium 2.63 into 10 raised to minus 8. Resistivity of silver 1.60 into 10 raised to minus 8. And resistivity of nickel 6.84 into 10 raised to minus 8 ohms. Answer. Substances which have low resistivity for electric current are good conductors of electricity. Silver has the least specific resistivity compared to the other conductors. Hence, it will be the best conductor. Third, if the resistance of wire A is 4 times the resistance of wire B, find the ratio of their cross-sectional areas. Answer. Resistance of a wire is directly proportional to the length of the wire and inversely proportional to the cross-sectional area. R is equal to rho L upon A, where rho is equal to specific resistivity, L is equal to length of wire, A is equal to cross-sectional area of the wire. Let the resistance of wire B be R, then resistance of wire A is 4R. If the length of the wire and material of the wire used for A and B is the same, then resistance depends on the cross-sectional area of the wire. Let cross-sectional area of wire A be small a and that of B be small b. Therefore, A is equal to rho L upon A, where rho is equal to specific resistance and L is equal to length of wire. Therefore, B is equal to rho L upon B. Taking ratio A is to B, 4R upon R is equal to rho 1 upon A divided by rho L upon B. Therefore, 4R upon R is equal to rho L upon A into B upon rho L, which equals 4 upon 1 is equal to A upon B. Hence, the cross-sectional area of wire A is 4 times larger than that of wire B. Fourth, two dissimilar bulbs are connected in series. Which bulb will be brighter? Hint: consider the resistance of the bulb. Answer: according to Ohm's law, R is equal to V upon I, where R is resistance, I is the amount of current, and V is the potential difference. Since the bulbs are connected in series, the same amount of current flows through the bulbs. A and B are two bulbs connected, and R1 and R2 are the resistances of the bulbs A and B respectively. Then R1 is equal to V1 upon I and R2 is equal to V2 upon I, where V1 and V2 are potential difference across the bulbs A and B respectively. If R1 is greater than R2, then electrical work done by a bulb is equal to VI. Therefore, work done by A is equal to V1I and by B is equal to V2I. V1I is greater than V2I. Therefore, V1 is greater than V2. Hence, the bulb A, whose resistance is more than bulb B, will glow brightly. Question 10. Solve the following. First, complete the following. A. 20 ohms plus 3.5 ohms plus 4.9 ohms is equal to R4 ohm. Solution. Rs is equal to R1 plus R2 plus R3. Substituting the values, R1 is equal to 20 ohms, R2 is equal to 3.5 ohms, R3 is equal to 4.9 ohms. Therefore, Rs is equal to 20 plus 3.5 plus 4.9 is equal to 28.4. R is equal to 28.42 ohms. 20 ohms plus 3.5 ohms plus 4.9 ohms is equal to 28.4 ohms. Therefore, answer is 20 ohms plus 3.5 ohms plus 4.9 ohms is equal to 28.4 ohms. B. Solution. Let R1 equal to 1 ohms, R2 equal to 2.2 ohms and R3 equal to 3.9 ohms. R1, R2 and R3 are connected in parallel, 1 upon Rp. Therefore, 1 upon Rp is equal to 1 upon 1 plus 1 upon 2.2 plus 1 upon 3.9, which equals 8.58 plus 3.9 plus 2.2 upon 8.58. 1 upon Rp is equal to 14.68 upon 8.58. Rp is equal to 8.58 upon 14.68. Rp is equal to 0.584 ohms. The answer is 1 upon 1 ohm plus 2.2 ohms plus 1 upon 3.9 ohms is equal to 0.584 ohms. Second, find the total resistance in the circuit. It is given R1 is equal to 8 ohms. R2 is equal to 12 ohms. R3 is equal to 7.2 ohms. What is Rp and Rs? Solution. First, 1 upon Rp is equal to 1 upon R1 plus 1 upon R2. 1 upon Rp is equal to 1 upon 8 ohms plus 1 upon 12 ohms. 1 upon Rp is equal to 3.2 upon 24. 1 upon Rp is equal to 5 upon 24. So, Rp is equal to 24 upon 5, which equals 4.8 ohms. Second, Rs is equal to Rp plus R3, which equals 4.8 ohms plus 7.2 ohms. Rs is equal to 12 ohms. Therefore, the answer is the total resistance in the circuit Rs is equal to 12 ohms. Third, find the total resistance and current in the circuit. It is given R1 is equal to 5 ohms, R2 is equal to 3 ohms, R3 is equal to 2 ohms. What is Rp and Rs? What is electric current I? Solution. First, Rs is equal to R2 plus R3, which equals 3 ohms plus 2 ohms. So, Rs is equal to 5 ohms. Second, 1 Rp is equal to 1 upon R1 plus 1 upon Rs, which equals 1 upon 5 ohms plus 1 upon 5 ohms, which equals 2 upon 5. Rp is equal to 5 upon 2. Therefore, Rp is equal to 2.5 ohms. Third, R is equal to V upon I. 2.5 ohms is equal to 4V upon I. Therefore, I is equal to 4 upon 2.5. I is equal to 1.6 ampere. So the answer is the total resistance is 2.5 ohms and total current in the circuit is 1.6 amperes. Fourth, if two resistors are connected in series, the total resistance is 45 ohms, and if the same resistors are connected in parallel, the total resistance becomes 10 ohms. Find the value of individual resistors. It is given resistance in series Rs is equal to 45 ohms. Resistance in parallel Rp is equal to 10 ohms. We have to find R1 and R2. Solution. First, when R1 and R2 are connected in series, equivalent resistance is 45 ohms. R1 plus R2 is equal to Rs. Therefore, R1 plus R2 is equal to 45. R2 is equal to 45 minus R1. Equation 1. Second, when R1 and R2 are connected in parallel, equivalent resistance is 10 ohms. Therefore, 1 upon R1 plus 1 upon R2 is equal to 1 upon Rp. Further, 1 upon R1 plus 1 upon R2 is equal to 1 upon 10. 1 upon R1 plus 1 upon 45 minus R1 is equal to 1 upon 10. R1 plus 45 minus R1 upon R1 bracket 45 minus R1 is equal to 1 upon 10. Further, 45 upon 45 R1 minus R1 square is equal to 1 upon 10. 450 is equal to 45 R1 minus R1 square. R1 square is equal to 45 R plus 450, which equals 0. R1 minus 30 into R1 minus 15 equals 0. R1 is equal to 30 ohms. R1 is equal to 30 is equal to 0, or R1 is equal to 15 equal to 0. R1 is equal to 30 ohms, or R1 is equal to 15 ohms. Therefore, when R1 is equal to 30 ohms, then R2 is equal to 15 ohms. And when R1 is equal to 15 ohms, then R2 is equal to 30 ohms. Answer: the two resistances are 15 ohms and 30 ohms.